Okay, so good evening everyone. I'm Shivani Dhok and I will be one of your TAs who will be coordinating the tutorial sessions for the course of simulations of communication systems using MATLAB, and I welcome you all for the week 1 tutorial of this session. So let's try to make this session interactive and the plan will be I'll have recap of every week's content. Like every week what I'll be doing is I'll quickly recap whatever has been done in that particular week, and after that we'll do some assignment questions. So those questions will be from last year's assignment, and those questions I'll try to cover. Along with that we'll try to do some MATLAB codes also. So this week one was a very introductory week, and nothing much was there in this particular week. Still, let us quickly start with the recap of this week's content. Okay, so we started with what is known as MATLAB, and we said that this MATLAB, so we can just this MATLAB into two parts. The first part indicates metrics, and the second part is simply laboratories. And this MATLAB is provided to us by a company called MathWorks. And we started with very simple things. What happened in MATLAB? What all things happen in MATLAB? So the first thing that we looked at was this MATLAB statements. So what do we mean by MATLAB statements? It's simply like if I have some variable, then I can simply write as y equal to 3. Then this is a statement which is simply saying that I am assigning y equal to 3. And then there are some other statements like I can have z equal to x plus y. So this is like adding two numbers. So these are simple MATLAB statements which we can execute. After that, we had looked at some simple but important basic MATLAB commands, which included help. So help command will allow us to look at or get some help on whatever inbuilt function which we want to use. So for example, if I want to find sine of a particular angle, like sine and cosine, let's say cos of a particular angle, then I can simply type help and MATLAB command is cos. So then it will give me with documentation of this entire thing. So this is how it works. So if I want to find help on a particular command, let's say it is cos, then I can simply write it here and just click on enter, and then it can give me the details of all of this thing. So what I'll do is I'll quickly increase the font size so that it's visible on small screens also. Yeah, okay. So if we type help cos, it gives me cos what that function does, and then it tells us what input it takes. So it takes the input, so it takes this input as x here, and it returns the cosine of all the elements of x here, and it also suggests us to look at different things that are related to this cosine function, like this a cos is um, cosine of inverse cos, then this is cos t function and cos phi function. Now the same thing you can do by searching here, that is simply typing. You have a cos function or a help button here. So if you look at your top right, you have a help option coming up here. So here again you can type cos and then click and enter. It will open a documentation window, and in that it will give you various options. And what we wanted to find out was simply this cos function, so we can click on that and look at it. And again it will give you the syntax. So it will give you the syntax of this particular function, then it will give you a description, and then it will give you some examples also. So it will help you in understanding how that function works. So it will give you example. Then these examples you can simply click on this open live script and run them in your own MATLAB, or simply just copy paste this like this in your command window and click enter. So it will simply generate whatever example was there for you. Another thing that we looked at is some additional commands, so which are useful. So this was the first help command. Then there are various commands that help us to clear all the things that are already present. So this particular area wherever we typed right now is known as command window. So if I want to clear this command window, I can simply type clc and it will clear the command window. And if these variables whatever we used are saved in this workspace, and if I want to clear the workspace, I can simply write clear all. So again I have nothing in my workspace. So this is how the basic MATLAB commands work. Another use of this help function here is if I want to figure out how things work out, or to find some particular command in uh, MATLAB, or find a command for a particular functionality in MATLAB, so we can just type it here and find it out. So MATLAB is a very friendly language in terms of documentation. So its documentation is really wonderful and it's very helpful. Okay, so then we looked at what is known as this variables. So these variables are basically identifiers. These variables are identifiers, and we can assign different values to it, and this can only consist of letters. Then we can have numbers, and we can have underscore. Okay, so what all things we can have is, so if I have, let's say, a equal to, let's say, 3, then this a is a valid variable name, and that you can find out here. And once it is there, we can get it here. Then if I save a123 as, let's say, some 10, it can also be seen here. And now if I want to find, let's say, sum of these two, so a underscore sum will be equal to a plus a123. So again you can see this a underscore sum is also a valid variable name. Now all combination of all three can also be a variable name. So again, underscore plus numbers and your letters are valid variable names. Again, if I have this a used here already, so I have this variable name a. Now if I allocate capital A as 4, so now if you can see in this workspace, small a, this little a, and this capital A, this lowercase a and this uppercase a, both are two different variables here. And if I do a minus small a, it will generate some result to me. which clearly means that the variables in this MATLAB are case sensitive. Okay, so this variable names, these are case sensitive. After that, we looked at different data types. So the first one we looked at was this integer data type, and this integer can be either signed or unsigned. And we saw that if it is an n bit, n bit signed, sorry, n bit unsigned integer, then it can take values from 0 to 2 to the power 2 to the power n minus 1, and this can take values from minus of 2 to the power n minus 1 to 2 to the power n minus 1 minus 1, and this can be in 8-bit or 16-bit, whatever we can go for. Then we have floating. So this is the default data type that we have in MATLAB. So this can be this floating thing is a standard, and it is given by IEEE 754 1985 standard, and this again has two options. One is single precision and another is double precision. So this single precision, is of 32 bits, and this double precision is of 64 bits, and there is a standard format for this. So how does this look? So I have this here, then I'll have an S, which is sign bit, then I'll have exponent, and after that I'll have fraction. Okay, so let's say this is E, this is F, and this is S. So how is this number saved? So any number x can be saved as minus 1 to the power s into 1 plus fraction into 2 to the power e minus bias. And this bias is the smallest value which can be saved, or which can be saved in the single precision or double precision thing. So I won't get into details of this exponent and floating point things. We don't need it in much detail. It's just needed to understand how things are going to happen, and how what the value of what is the maximum value of floating points which we can work with. So this range for double precision and single precision is more than sufficient with whatever values we'll be using for simulation. And this double precision floating point is the default thing that is being used in MATLAB. So you can see that here. So if I add class here, so you can see that the default class of all the variables that are being generated by us is double. So this double means we are using double precision floating point. And if you want to typecast it to a particular kind of variable type, then we need to specify while specifying these things. For example, if I set, let's use different thing. If I set b as unsigned integer 8 and 1, so now this class will be unsigned integer 8. Otherwise, by default, it will be in double. Okay, there are too many things. Let's clear them. Okay. Okay, so after that we looked at characters and string, and after that we looked at floating point addition and multiplication. So we saw how this floating point addition and multiplication will be done. Then we looked at what is known as computational complexity, and we said that we want to minimize this computational complexity, and this is in terms of the number of floating point operations. For example, addition is one floating point operation, multiplication is another floating point operation. So we want to minimize the computational complexity in terms of the number of FLOP or flops that are needed to run that particular code. After that, another class of operators we looked at, and this is the, okay, so I missed on a point here. So before going on to logical operators, we looked at arithmetic operators. So there are various arithmetic operators like addition, multiplication, subtraction, division, exponents, etc. And like BODMAS rule, we have BODMAS rule for this also. And importance is first given to the nested bracket. Then more important are brackets. After that we'll have exponents. Then we'll be looking at multiplication, division, and yeah, modulo operation. And after that we'll have addition and subtraction. And these things, if they occur in like simultaneously, so these will be handled from left to right, and same thing, it will be handled from left to right. For example, if I have x plus 2 minus y, then it will first solve x plus 2, it will get its answer, and then it will solve whatever value, let's say z, it will give, then it will solve z minus y. So like this it will solve from left to right. So these are the arithmetic operators which we have. And after that we looked at different logical operators. So these logical operators will provide us an output. They will output logical data type. That is, it will output either 0 or 1. And there are various logical operators. And why do we need these logical operators? To check certain conditions which have their use in getting into loops and other stuff. So the logical operators which we have are, this is first one. So this is greater than, then we have this thing. So this is greater than and equal to. Then similarly we'll have less than, and equal to, Then we have this. This is not equal to. And then we have, is it equal to? So these are some logical operators in MATLAB. So let us try to see how these work. Close this also. Yeah. So the first one, let us see is, okay, I have this x equal to 2. Another variable, let it be y equal to 4. And let's have z equal to, again, 2. Then the first operator which we can check is equal to sign. So let us check if x is equal to y. So it gives me an answer logical 0, and if you see its value is 0. So this logical data type will take value either 0 or 1. Now let us check the same thing for z. So this z has a value of 2, and therefore, and x also has a value of 2, so x equal to z is equal to 2, and therefore this is simply logical. It is returning me a value of logical 1, which means that x and z are equal. Next operator was x greater than or equal to, or greater than or equal to. So this is x greater than or equal to z, so it gives me a logic 1. Now if I do x greater than z, it is giving me logic 0 because x is 2 and z is 2. So it is not greater than, it's simply equal to. Similarly, if I have x greater than y, it will return to me a logic value 0. Another thing was x not equal to y. It is giving me a logic 1 because x is equal to 2 and y is equal to 4. Similarly, if I do x not equal to z, it will return me a value 0. So these are some of the logical operators which we can use in this MATLAB. Okay. Then after that, what we looked at was, let me add a page. Okay. So we looked at these logical operators just now. Next thing that we looked at was the script. Scripts. And the scripts are basically text files. And these text files are saved with .m extension. And these are basically just collection of your commands which you want to execute sequentially. So we can say that this is like collection of commands that we want to execute sequentially. And we can save these things. So if you want to reuse the same code multiple times, you can simply do that. So again, let's get back to our MATLAB thing. So this is my command window. Now what I want to do is I want to add a script. So that I can do from here, new script. I can add a new script from the option which is in home and in the top left corner, or I can press Ctrl N. So if I do Ctrl N, it will create a new script which I can save afterwards. So right now it is untitled. So what we can do is, in practice, generally what we do is any code which we write, it should start with these commands. That is CLC. The CLC will clear whatever is there in my command window. So it is clear command window. Then I have clear all. So it will clear all the variables whatever were there already in my workspace. And this close all will close all the other figure windows and other windows which are open. And this is like a nice way to do it, because many times whatever variables are already stored in the previous from the previous code may be used, or with the same variable names we might have another variable which are there in this particular code. And if we don't clear the values which are there in the previous code and directly use it in this newer code, it might happen that it takes up, or the code uses the wrong values of the variables that we want. And in order to remove this ambiguity, it's nice to start our code with this particular line. Okay, so now let us start with a simple addition code. Let's define our variables x equal to 2, y equal to 5, and let's save sum x y as x plus y. And now let us try to run this. So if I directly click on trying to run this command, it will prompt me to save this particular code. So let us try to save it. So what I can do is I'll try to save it with the name sum. Okay, it ran. Now what I'll do is I'll take this same thing here, copy here, and try to save it. And what I'll do is I'll try to save it like this, sum space new. Now it won't allow me to save this function because you can't use spaces. And if I remove this space and substitute, or if I replace this space by an underscore, it will run. Okay, another thing is, okay, this is saved. Another thing is this earlier one, if I run this, so okay, so yeah, this is what I am having here. Okay, so this is how you generally create your MATLAB scripts. Then after that, we looked at flow of controls. So there were different flow of controls. So the first one was this while loop. So what this while loop does, it runs a set of commands till the point a condition is satisfied. Okay. Then there is another thing. We have this if. So this if loop, or if control flow, what it does is it runs a set of commands if the condition is satisfied. And the last one, or last flow of control that we looked at, was this for loop. So what it does is we have something called as iterables. So it runs the set of commands for all the iterables. Okay. So let us try to do something with this while loop and if loop. Okay, so let me create a new script. Oh, we'll do very simple things. So what I'll do is I'll initiate a variable, let's say 10, and then what I'll do, while k is greater than 0, then I'll do display k equal to num to str k end. Okay, and then I'll simply run this. Okay, so now what's happening is it's constantly running this particular code. It's not stopping. Why? Because the value of this k is not getting decremented, or it is not changing only inside this loop, which means that this particular code is now stuck in infinite loop. Now in order to get out of this infinite loop, what I need to do, we need to simply do Control C, and that will just stop execution of this. So what it says is it will give me some sort of warning or error kind of thing, and it will say the operation terminated by user during while example. Now I want to get outside this while loop, which means that this particular k value or this variable, so this um, condition for getting out of this while loop is this k should be equal to 0. Once once the k is equal to 0, I'll get outside this loop. So what I can do is I can simply decrement this k by 1 every time, and now let's see what happens. So now what is happening is I'm getting this is getting displayed for all the 10 values, and after this after this particular thing, this k is now equal to, so if you see here in workspace, this k is equal to 0. This k value is now equal to 0, which means that the k is not greater than 0, and therefore it will just come outside the loop. So this is a simple example for while loop. Then there is another control flow. Okay, so in this what we'll do, we'll simply check if the number is even or odd, and here what we'll do, we'll ask the user to give me an input. So what I'll do is this x is equal to input, enter the value of x. Then what I can do is if remainder, so I want to find the remainder of this number. So I don't know the command, so what I'll do is I'll try to figure out with the help functionality which is there in MATLAB. So I just typed remainder in the um, help function, and then it will give me suggestions what to use. So remainder after division, it is giving me this particular thing, and then it is giving me the syntax. So it says this remain r equal to rem a comma b returns the remainder after division of a by b, and that is exactly the thing that I want. So if remainder of x when divided by 2 is not equal to 0, then display x is even, sorry, odd. Else display x is even. Okay, so now it's asking me to enter the value of, okay, let me just clear it and add a space here. Okay, so it's asking me to enter the value of x. So I entered 4, x is even, same thing. Then I enter 3 and x is odd. Okay, so this we have seen in example that was taken in lectures also, that if I want to run a particular script, I can simply type its name and click enter. So it will run and then can simply run that particular code here. Another thing is, and right now my cursor is in command window. Now if I click on, if I press the up arrow button in my keyboard, then it will give me whatever commands I had typed earlier. So it is giving me the history of whatever things I have done since the time I have been using this MATLAB. So I have all these things what I have been using, and it will tell me on what date I had used it. So this help course is something, or from help course, it's something that I have been using today in today's session. So it's giving me that today you have typed all of these commands and got the output for all of these commands. Okay, so it's simple that you don't need to type the same thing again and again. You can simply click on up arrow and just run the code, or simply run the code. Another thing is, if I want to run a particular part of this code, something like this, then I can select this and press F5. So if I do that, only that, oh sorry, it ran entirely. Yeah, sorry, not F5. If I press F5, then it will run the entire code. If I press F9, or like this, if I do, it will just run only that particular part of code which I have selected. Okay, so this is all about if loop, and the last loop which we want to see is for loop. So here let me create something what is known as iterable. So this is 1 minus 1 minus 2 4 7 10 11. Then what I'll do is for I equal to x, display num2 str of I plus 10, or let's not complicate, ir plus 1. And another thing you should notice is every loop thing, or if I am starting with while loop, I am ending it with an end statement. Similarly, if I have an if loop, I am ending it with an end statement. If I have a for loop here, I have to end it with an end statement. So let's run this. So it will just give me the values of these plus 1. Now this x I can also write as 1 1 10. So what it will do is it will simply generate iterables from 1 to 10, or I can do 10 minus 1 and 1. So it will decrement it by 1 value and start from 1. So something like this. Another way of doing this is I can do linspace 1 10, and how many values I want? 10. So like this I can do. So starting from 1, so this is the first value, start point, this is the stop point, and how many values do you want between your start and stop point. For example, if I do 5 here, then it will just give me 5 values. So 2, then 3.25, then 5.5, 7.75 and 11. So like this it will behave. Okay, so this is another way of generating long sequence instead of manually getting a step size and then figuring it out. Okay, so this is all about for loop. And after that, we looked at what is known as function. So this function is a callable subroutine. So it actually creates an abstraction. We don't know what all things are happening inside that particular loop, or inside, or we are not interested in commands or the way it is being coded. What we want is only the final output. So for that, what we can do is we can simply create a function. Second. Okay. Okay, so what we can do is, let's say I need to do this same thing, I need to repeat, but by using a function. So what I'll do is I'll take this, then I'll create a function, and what it will return is, let's say, y is equal to, is it, or is it even. It will also end, and then I have it something like this. It won't return anything, and x something like this. And now if I save it, oh yeah, sorry, yeah, now it will ask me to save it, and it will save with the same name as the function which we have given, and therefore I can save it here like this. Now let me just, so what I can do is it even 10. So it just prints yes, it is even. Then if I give it 1, then it just gives 1. Same thing I can, so I can replace this entire block in my if example by is it even and x. Okay, so I can run it. I'll enter the value of 10, and then is it even. So I don't want to see what is happening and what logic I'm using to figuring it out. I just want a function that will simply tell me what is happening, and it should simply give me the value of whatever it is returning. I am not interested the way things are coded in this thing. So this is useful when I'm having a huge code, and that huge code has subparts. So each subpart I can simply write a function for that subpart and get the values or output for those subparts through the function, and simply supply the output of one function to another so that my entire code runs. When we go ahead and look at higher level examples for simulation of MATLAB, we'll get into such kind of examples. Okay, so let me minimize this first. Okay. Okay, so this was all that was covered in the first week content. If you have any queries, then please ask me here. Otherwise, I'll move on to the assignment questions that were there in the last year's assignment. I'll wait for 1 minute. If you have any questions of regarding all of these things, then please ask. Please unmute yourself and ask, because I'm not able to see the chat box of this Google Meet. Okay. Okay, if there are no questions, then let me move on to questions that I have planned to cover today. So in the beginning of today's session, I had mentioned that I will be taking up the questions which are there, which were there in last year's assignment, so that it will help you in answering whatever assignment questions are there in this year's assignment, hopefully, because most of the times the questions are similar and in the same pattern. So this kind of exercise will help you all. So let me start. So the first question that we have here is the largest value that can be stored as an 8-bit unsigned integer. So it is asking me regarding 8-bit unsigned integer. So if I have, so for n-bit unsigned integer, maximum value which can be stored is 2 to the power n minus 1. So here n is 8, therefore 2 to the power n minus 1 will be equal to 2 to the power 8 minus 1. So this is equal to 2 to the power 8 is 256 minus 1, it is equal to 255. So the maximum value which can be saved or stored using unsigned integer is 255. Okay, let us try to see if the answer that we have here is correct using MATLAB. Okay, so let me just pull this up and let me clear the workspace. And okay, so what we had, 8-bit unsigned integer. So how can I get 8-bit unsigned integer? So I need to declare it as 8-bit unsigned integer. So u int 8, and if I have 100, yeah, okay, I can get an x with value 100. If I have 255, okay, fine, I can save 255. Let's see what happens if I overshoot this. If I say x is equal to u int 8 256, but no, it will set x as 255. So anything above 255 will be stored as 255. So even if I give something like this, it will be just saved as 255. Okay, this is happening because we are having 8-bit unsigned integer. But if I have 8-bit or 16-bit and try to save this, okay, it can be saved. But again, if I try to have a very large number to be saved as unsigned integer 16, no, it won't allow me to save it, because again I will be limited by 2 to the power n minus 1, which is this particular value. Okay, so therefore for an n-bit unsigned integer, the maximum value which can be stored is 2 to the power n minus 1, and therefore in our example what we get is simply 255. Any questions? This is a very basic introductory week. It doesn't have any difficult questions coming up, but still it's good to know these facts that are there in MATLAB and how the basic things happen in MATLAB. Okay. If not, then let me quickly move on to the next question. So here what is asked is a single precision floating point has n bit exponent and m bit significand. So what are the values of this n and m that we need to find out. So this is floating point. We had seen the structure of this floating point, which was something like this. Okay, so let me draw it properly. Okay, so what we had this s, then we had exponent, so we have n bit exponent, and then we had this m bit fraction. And for single precision, this entire thing, for single precision, this entire thing is of 32 bits. Okay, this s here is of 1 bit. Then here it is given as n bits and here it is m bits. Now since it is a single precision and it's 32 bits, obviously these options are gone. And what is left with us is option 1 and option 2. So now if you observe carefully, if 1 bit is gone in s bit, the remaining thing will be available for n bit exponent and n bit fraction. So these exponents are of 8 bits. And this m bit will be 32 minus 8 minus 1, and that comes out to be equal to 23. So for a single precision, floating point number, we have 1 bit sign bit, then we have 8 bits of exponent, and then we have 23 bits of fraction. And this thing entirely is of 32 bits. Okay. Any questions? Okay. If there are no questions, then let me move on to the next question quickly. Okay. So now what it's asking us is, which of the following is not a valid variable name? Okay, so what did we see? A valid variable name is a combination of 1 letters 2 numbers and 3 underscore. Anything else uh, or anything other than all of these things are not allowed in a valid variable name. So now if you observe carefully, if you look at this first thing, it is y34a. So now you observe it has only letters and numbers, and therefore yes, okay, this is a valid variable name. Another thing is, next one is 2x94. This also contains numbers and letters, okay, but let's see if it is through MATLAB. Next one is 41a exclamation mark. Now this symbol is exclamation mark, which means that it is not an underscore. Any symbol other than underscore is not allowed. So again, but still we'll confirm it through MATLAB. And next thing is v at the rate symbol and r. Again, this symbol is at the rate. So again, no, I can't. So still we'll check it. So the first variable name that let's try to figure out if it is correct through MATLAB. So the first variable name that is given to us is y34a. So it was y34a. Okay, yeah, it's not giving any error, and therefore, yeah, okay, this is a valid variable name. Next, okay, so what we checked is, okay, this is a valid variable name. So let me write it properly. This is a valid variable name. Now let us see the next one. It is 2x94. So what it is? 2x94 is equal to, let's say, 15. Okay, so now it is giving an error. It says that invalid expression. Check for missing multiplication operator, missing or unbalanced delimiters, or other syntax error. To construct matrices, use brackets instead of parentheses. Now, what is happening here is, we have a number here, and then we are having this x94 here. So what MATLAB is thinking is, this x94 is another variable, and this 2, and what we want to do is, we want to multiply this x94 by 2. So what is happening here is, this variable name, since it is starting with a number, it is not parsing it properly. So now and it's suggesting me, do you mean that you want to have a variable with name which is something like this? So now if I set it as x94 equal to 15, okay, that is a valid variable name. However, if I start a variable name with a number, it's not a valid variable name. It will give me error. Okay, so this thing here, even though it just consists of numbers and letters, this is not a valid variable name. And what did we see? These numbers should not come at the beginning. Okay, now let us look at the third one, which is 41a exclamation mark. So it was 41a exclamation mark. Again, it is, oh sorry, let's try to assign something to it. So first, Like a first flag to me that something is wrong is this color. Color is not normal color. So if you see, it's a simple black here. Everywhere it's simple black. So there is something wrong that's giving me. So okay, let me add. So it is again giving me invalid expression. Same error. Now even if so again this is not a valid expression, but okay, one thing is it started with a number, so of course it is not a valid expression, valid variable name. But now again, let's see, if I start with an alphabet and have this exclamation mark, is it a valid variable name? So no, it's not a valid variable name, and it's suggesting me if I want to calculate a factorial of a or what. Okay, so again that is not a valid variable name. Okay, so this is not a valid variable name. So not a valid variable name. Why? One, it starts with number, and two, it has exclamation mark. Now let us try to figure out if this one, the last one, is also a valid variable name or not. So it was v at the rate a equal to 15. No. So again, it's giving me an error. Assigning the function output to this expression is not supported. Okay, this at the rate has some significance somewhere in MATLAB which we don't know. Again, this is some sort of symbol, and therefore again we can't use it in MATLAB. Another thing is, can we use underscore at the beginning? So if I have variable name equal to 16, again it's saying invalid text or character, check unsupported symbol. So again, if you see, I can use this underscore at the beginning. So if you look at this carefully, this thing here is of some random color, some different color than black. So if something is wrong, this MATLAB will give me an indication that okay, something weird is happening by doing some sort of color coding. So what did we see is, I can't have this any kind of symbols like exclamation, at the rate, and other symbols in variable names. Next thing we saw is, I can't have a variable name starting with a number, and I can't have a variable name which is starting with underscore. Okay, so what we have seen just now is, this is again not a valid variable name because it has at the rate symbol. And another thing is, this underscore also should not come at the beginning. So a valid variable name should start with an alphabet. All variables should start with this. Okay, so the question that was asked to us was, which of the following is not a valid variable name? So we saw that the first one is valid variable name. The second one is not a valid variable name. So therefore our answer is this second one, then third one, and this fourth one. So these three are the correct answers. Any questions? Okay. If there are no questions, then I'll quickly move on to the fourth question. Okay. So the question here is a floating point number. So we have a floating point number with all zero exponents and non-zero significant. And what does this mean? So this condition is for denormalized numbers. So for a denormalized numbers, what we have is the exponent bits are all zeros and significant bits are non-zero. Now this thing here is a standard thing. This has no logic. This is something that is being specified in the IEEE standards. So this is like an information. And we can't do anything, or we can't have any logic to remember this. The only logic for 0 and infinity we can have, not for these things. But okay, this is a standard thing, and this is a fact that we should take care of. That if I have a denormalized number, then its exponent bits will be all 0 and significant bit will be non-zero. Okay, so that was a factual question, and let's move on to the next coding related question. So this question here is a while loop executes, sorry, a while loop executes the loop at least once before checking the condition. So what it's saying is, if I write a code which is something like this, or okay, instead of writing here, let me just move on to MATLAB and see what happens. Okay. So we had this while example. So I'll just clear all of these things. Okay. Okay. So what's happening here is, this is what's happening. So my while loop, the condition for my while loop is, if my value of k is greater than 0, then this set of code, this set of lines should be executed. So here k was equal to 10, and therefore it started running and it ran. Now the question is, at this particular point, when I'm setting the value of k equal to 0, it says that this set of lines will run at least once, or without checking this particular condition. So let's see if it runs. No, nothing was displayed. So at this particular point, my k is equal to 0, k is not greater than 0, which clearly indicates that this particular thing, this while loop is condition is not satisfied, and there, since the condition is not satisfied, it doesn't get inside the while loop and it does not execute. Now if I make this k as 1, then okay, it will run one time. At this particular instance, after this is being displayed, I am decrementing this k by 1. At this point, the value of k becomes 0, and therefore now I'll get out of this while loop. So I can add breakpoints like this to see how what's happening here. Now here I have displayed the value of k. Then if I press continue here, at this particular point, the value of k has now become 0. Now if I put, okay, I'll put step here, and now okay, since the k value was now equal to 0, it simply didn't satisfy the while loop condition, it came outside. So right now what I added was something like this. So these numbers are here, right, line numbers. You can click on this And you can add a breakpoint or pause the execution of your code by adding a breakpoint, just to figure out or just to debug the code, like what is happening at each step we can figure out. This is useful when we'll write big codes and we don't get the desirable or desired output. Then we can simply look at each and every line and figure out what is the issue or where is the issue. Okay, so let's get back to the question that we had. So the question that we have is, the while loop executes the loop at least once before checking the condition. So this thing is false. So what while loop does? It executes the set of commands only if the condition for while loop, or instead of if, only till the condition of while loop is satisfied. Okay, any questions here? Okay, if there are no questions, then let me move on to the sixth question. So the sixth question says, which of the following operations will lead to NaN or not a number value? Okay, so the first thing that we are having here is sine 0 by 0. So we know that sine 0 is 0 by 0, and this form will give me a nan. Another next option that we have here is cos 0 by 0. Cos 0 is 1, so 1 by 0. This will give me infinity. Then infinity minus infinity will give me a nan. There's no sense in this statement mathematically, but infinity plus infinity will give me infinity here. So let's see what's happening. Okay, so first thing that we had, let me okay, so we had sine of 0 by 0, so this gives us nan. Then we had cos of 0 by 0, this gives us infinity. Then we had infinity plus infinity, this gives us infinity. Then we have infinity minus infinity, this gives up not a number. Okay, so what we had seen was 0 by 0 form. Another thing that we can see is infinity divided by infinity. This will also give us a nan or not a number. If we do this, again it will give me a not a number. So all the invalid operations or invalid mathematical operations that we have, that is 0 by 0, then infinity by infinity, then 0 into infinity, then infinity minus infinity. All of these are invalid operations and all of these will give me nan values. Okay. So the question asked was, which of the following operations will lead to not a number or nan values? So the answer to this is this one and this one. Any questions?
Ma'am, these only four value are there for
Sorry,
nan. Only four term are there for nan. 0 by 0, infinity by infinity, or
all the invalid operations in math, whatever invalid operations in math are there now.
okay.
So
Can we take 1 to the power infinity is also like a nan value or 1?
I think in only in MATLAB,
Okay. In MATLAB only four are.
yes, it gives one.
Okay,
That
okay,
is
fine.
a bug. Like this is how MATLAB coding is done. So only here in MATLAB, 1 to the power infinity is 1. So
Okay.
even though in math sense it is an invalid thing, but okay, here, so I'll just add a note here. In MATLAB, 1 power infinity is 1, where this is not mathematically true. So just be careful.
Okay,
Other
ma'am.
than that, all the invalid mathematical operations will lead to nan values. And this nan is a problematic thing. This propagates. So for example, if I do, 1 second, it won't be, minimize this. Okay. So if I do sine 0 by 0 plus 1, still it will give a not a number. So this nan, this particular part is generating a nan value. So in all the subsequent answer or subsequent things, this nan will go on propagating. So therefore, one invalid operation will create or generate a nan and it will simply propagate further. And there is
Thank you.
another way to check if a nan is being generated. So there is a function which is called as isNan. Then it will generate some. If it is, if its argument or function input is generating a nan, it will return a logical 1. If it is not, then it will return a logic 0. So this function is also useful when in our final course somehow my answer is coming as nan and I don't know where this nan value is getting generated. So after each step we can just put this command and check if a nan is being generated at that particular place or it is generated somewhere, or we can use or we can make use of these simple functions to figure out the bugs in our code. Any other questions?
Thank you.
Okay, if there are no further questions, I'll move on to the next question. So the next question says that which of the following is not a logical operator? So we have discussed this. So we had seen that this particular thing is a logical operator. It is greater than or equal to, then this is not equal to, this is check if equal to, and this thing here which is simple equal to sign, this thing is an assignment operator. Okay, Okay, we had seen this, but still we have time, so we can revisit this. Okay, so I can do, so first one was greater than or equal to, so 3 greater than or equal to 2, so it returns a value like this. Then we can write 2 greater than or equal to 3, then it will return a 0 because 2 is less than 3. Then we can have 2 not equal to 3, it returns a 1. If it is 2 equal not equal to 2, then it will return 0. Then 2 equal to 2, it will return 1. 2 equal to 3, it will return 1. Now if I use something like this, x equal to 2, it will create a variable which is of name x and has a value 2. Now if I do 2 equal to 3, then it will create, give you an error. It will say that there is an incorrect use of operator or equality operator. Assign a value to variable using equal and compare values for equality using double equal to sign. So this MATLAB is nice in this sense that it will try to help you in coding with the errors that it will generate. So it will try to help you in finding the bugs also. It will direct you on how to figure out where the error is. So now if I put 2 equal to 3, it will run and it will give me a logic 0. Okay. Any questions in this part? So the answer to this is, this thing here is not a logical operator. All others are logical operators. So this one, and this one are logical operators. Okay. Any questions in this part? Okay. If not, then I'll move on to the next question. So next question is, what shall be done if one gets stuck in an infinite loop? So this we had seen. So we had seen this earlier, that we need to press Control C. So the answer to this question is, we need to press Control C, and this Control C here stops the running code. And this helps us in getting out of the infinite loop. So this allows us to get out of infinite loop. So let us just quickly see that example again. So what is infinite loop? The loop continues to run on and on. So simply if I comment this thing, so Control R is shortcut for commenting and percentage sign is used for comment. And if I run this command, now my k is equal to 0. K is equal to 1 initially, and if k is greater than 0, then I'll continuously display this value. So if I run this, it will continuously go on displaying 1, k equal to 1, k equal to 1. Why? Because I am not able to satisfy the exit condition of this loop. And it will never get satisfied because I am not stopping, or I am not decrementing the value of 1, or I am not modifying the value of 1, so that somewhere it will be less than 0. So this loop will go on running till infinity, and such kind of loops are known as infinity loop. And in order to get out of this infinity loop, we can simply press Ctrl C. And once we do that, it will give some random error, but it's fine. It's just saying that we stopped the code in between. So this was a simple example of infinity loop and what we can do. And small thing that I just told was this control R. This control R is simply used for commenting, or shortcut for commenting. This side information. Another thing is, if to remove the comments, we can use control plus T. So remove means not delete, but if if something you have commented, like for example here, if this part of code, if you had commented and I want to uncomment it, then I can use control T. So instead of writing to remove comment, I can simply write to uncomment. This is again some side information. These are useful when I need to comment and uncomment multiple lines of code. Instead of manually commenting each and every line or uncommenting each and every line, I can simply select all of these and press Ctrl R and Ctrl T to comment and uncomment. Okay, so what allows us, or what helps us in getting out of the infinite loop? It is Ctrl C, which allows us to stop the running code. Okay, so here last two questions are just for fun, because some math related things were discussed, like how to do addition and subtraction. So how to do subtraction using 2's complement. Since it was mentioned, I thought I'll just add two simple questions which we know how it is done, but still. So this question, what it's asking us is to find the 2's complement of the following binary string. So the binary string that we have is 1 0 0 0 1 0 0 1 1 0. So what we do is we first take the first one's complement, that is simply flip the bits. So we'll simply flip the bits like this. So this thing here, from going from here to here, is taking one's complement. And in order to get 2's complement, what we do is we simply add 1. So this 1 plus 1 is 0. We have a carry here. So 0 plus 1 is 1. And then there is no carry, so I can simply add this. So this thing here, is 2's complement of the given binary string. It's a simple thing. This is simple. This we have done in Boolean algebra course, or maybe in digital circuit course. This is also something that we had done in digital circuit course, and it says that perform the following operations with 4-bit binary string. And first one is 2 plus 1. So let's start with this one first. 2 plus 3. So this 2 thing in decimal is equal to 1 0 in binary, but if I have 4-bit, I can simply append 2 zeros here, and then we can write it as 3 in decimal is equal to 0 0 1 1, in binary, and this thing in adding I can just do element by element addition. So 0 plus 1 is 1, 1 plus 1 is 0, but a carry 1, then 1 here and 0. And this thing in decimal will be 5. Okay, this is simple addition that we have been doing in digital circuits course. And next thing is subtraction, this one. And this again is for 4-bit, and we'll use 2's complement method. So this 2 minus 3 I can write as 2 plus minus 3. So this 2, we have seen that this 2 in binary can be written as 0 0 1 0. I want to write this 3 in 2's complement form. So first of all, what we'll do is we'll take this 3 and then take its 2's complement. So for that I'll do 1 1 0 0 plus 1 like this. So this will be 1 0 1 1. So now we'll do this 2 minus 3, and this will be equal to 0 0 1 0 and 1 1 0 1. So now if I add it, it will be 1 0, sorry, 1 1 1 1. Now this MSB here, this MSB here is 1, which means that the subtraction is negative. And again I can take the 2's complement of this, so it will be 0 0 0 0 plus 1, and this is equal to 0 0 0 1, which means that the answer is minus 1 in decimal. Okay, so these two are the simple questions, just for fun I had added. These are all the questions that I had planned to cover today. If you have any other questions, then please ask. If you have any questions, then please ask. Otherwise, you are free to leave the meeting. The recording of today's session I'll upload on YouTube on my channel. The link will be there on uh, on the portal for NPTEL soon. And you can also just search my name. I'm Shivani Dhok. You can search my name on YouTube to find the link of today's recording. Thank you for attending today's session. If you have any queries, then please feel free to ask. Otherwise, you're free to leave the meeting.